Hello guys and welcome. I hope that you're having a good day or a good morning or a good evening. My name is I play 4K, aka I play 8K, aka I play 16K, or UHD King. During this video today, I'm going to show you Mortal Kombat XL or 10L running in 16K resolution, rendered in real time 133 megapixels on a single Titan RTX video card and the old school Xeon E5-2697 V2 CPU socket 2011 version 1 X79 chipset. Guys, during this video I'm just going to show you my workstation from 2020. In 2021 I'm going to have two Xeon E5-2699 V3, but this is on an X79 chipset, top of the line Xeon E5-2697 V2, what you can get for the single socket. And let's go ahead and have a look how with the decent video cards such as Turing GPU architecture, TU102 GPU that is powering this Titan RTX, and 24 GB of VRAM, we can play this game different presets, 16K resolution. So I'm going to start with 15,360 pixels by 8,640 pixels. I'm going to run it in windowed mode. We can run it in windowed full screen, in a full screen or windowed. Full screen is kind of flickering sometimes the textures. So I decided to go ahead and run it in the windowed mode. Keep in mind that my desktop is set in 16K resolution as well, 100% scale. After the gameplay and benchmarks, I'm going to show you my hardware specification through the CPU Z, either 64, GPU Z, so stick around, and I'm going to show you how my desktop is set to 16K resolution. So this is how we're gonna do that, guys, and this is how I'm going to do it. So this is pretty much going to be the lowest possible settings. As you can see, we're going to start with the lowest possible settings, and then we're going to improve the settings. Let me go ahead and do something like that. Okay. Texture quality, of course, we want to have the highest possible, because what's the point to run 16K resolution? So this is how we're going to apply. So this is the lowest possible settings, but still very hardcore, because this is 16K resolution. I'm going to use in-game benchmark. Wow, I'm going to use it as a thumbnail. Because as you can see, my Xeon E5-2697 V2 CPU comes with 12 physical cores, and when hyper-threading technology is enabled, it's going to be 24 threads or 24 virtual cores. But I disabled 10 physical cores and I disabled the hyper-threading technology, so I'm only running 2 physical cores, 2 physical threads for the maximum possible performance, because this CPU is enterprise CPU and it has the multiplier locked. So I cannot overclock it through the multiplier, even if I'm running it on a gaming overclocking motherboard such as Gigabyte X79 Ultra Durable 3 version 1.1. They have 20 BIOS, the latest BIOS for this motherboard. So the turbo boost is automatically controlled by the CPU and the chipset. So to be able to use the maximum possible multiplier in our turbo boost, we can use one core, which is 35 multiplier, 2 cores 34 multiplier, 3 cores 33 multiplier, and 4 cores 32 multiplier, 5 cores 31 multiplier, and 12 physical cores, and hyper-threading technology will be 30 multiplier. Keep that in mind. So you saw it, guys, not so bad. Performance is again this 16K resolution on a single Titan RTX video card. And let's go ahead and maxed out right now the visuals, because I'm coming in real time. As you can see, it's kind of hard to comment and see what's going on the screen at the same time, but you want to keep your eye at the left top corner, my GPU utilization, which is right now 93% during the menu, and my CPU utilization which will never reach above 80%, which means that 2 core 2 threads is more than enough for this game. Keep that in mind. So right now I'm going to go ahead and max out everything except the motion blur. Okay, everything maximum possible preset. And this is, guys, on the Titan RTX that's running constant right now at stock. I did not overclock the Titan RTX yet. By overclocking the Titan RTX through the software, and this is exactly how I'm going to do it, we're going to improve by 10% of the performance for free. And I'm going to show it to you in a second. So let's go ahead and run the benchmark right now with everything maximum possible visuals. But Titan RTX is still running stock, and I'm about to overclock it after this benchmark. The game looks absolutely amazing in 16K resolution, as you can see, guys. Pretty much 133 megapixels. Every single detail of that texture is popping here, and every single detail of the texture is loaded. Beautiful visuals, but as again, single Titan RTX video card is not enough to play this game with comfortable FPS. I would say comfortable FPS for this game will be starting at 45 FPS. But keep in mind that I'm recording right now this gameplay, guys, this benchmark with Nvidia Shadow Play software on the same computer that's utilizing my video card resources. So without the recording, please add 3 FPS to the FPS counter. So it's going to be 3 FPS additional every second without the recording, because it's recording on the same computer using the Nvidia Shadow Play. But I'm not using the RTX audio through my mic, otherwise it would take additional 5 FPS, while it's going to remove some noise on the background through the audio processing. Still low, but as again, this was running on stock Titan RTX stock. So let's go ahead and improve the Titan RTX, guys, and we're going to pretty much overclock the Titan RTX. Look how small my mouse cursor right there. Just unbelievable small. As you can see, all the apps for 16K resolution, 100% scale, just like our desktop. So I'm going to improve, I'm going to overclock my video RAM, which is the VRAM, by 1000 megahertz, which is GDDR6 will be additional by 2 times, which is 2000 megahertz. So from 14,000 megahertz on the VRAM, we're going to go to 16,000 megahertz overclock, and plus additional 100 megahertz on our GPU. Let's go ahead and do that. Okay, I just done so. Okay, zoom out, and right now the same maxed out benchmark as you just saw, but when the Titan RTX is overclocked now, should be 10% higher performance. Let's go now look. So let's say about 2 FPS higher we should have. Yep, instead of 20 FPS, we're at now 22, 23 FPS. You can immediately tell. Because I'm also going to record on this workstation 8K resolution in Mortal Kombat XL or 10L, whatever you want to call it. Pretty much it's Mortal Kombat 10 plus the add-ons. But there is another Mortal Kombat is available already, Mortal Kombat 11, and I'm going to record a video from the Mortal Kombat 11 for you as well. But as again, this is the world's first 16K resolution in Mortal Kombat 10 or X, guys, or XL, whatever you want to call it. The world's first, guys, gameplay and benchmark 16K resolution. And as again, how I achieved that: 8K resolution native screen plus Nvidia DSR method. It's not the third-party DSR method, but Nvidia DSR method. Alright, so we saw the FPS. Pretty much this is what it is, guys. Let me close the game, and we're going to go ahead and jump in and have a look what we have over here. So first of all, let me show you what kind of system we are running. So this is the IDA64 GPU benchmark, as you can see, guys, at the left top corner, where it's pretty much benched through the OpenCL, and we can compare the GPU versus the CPU. But CPUs again was running only 2 core 2 threads, even if this CPU is 24 threads. As again, this CPU is monster when 24 threads are open. But keep in mind, guys, that this 24 threads on this CPU will be a hair slower than i9-9900K running completely stock with 8 cores, 16 threads. But as again, that CPU is 9 gen, and this CPU is considered as 4 gen. So pretty much the Intel Core i7 4000 series i7 CPUs will be equal to this CPU cores on this Xeon E5-2600 series V2. But Core i9 9900K completely running stock, 8 cores, 8 physical cores, and 16 threads, will guys be faster in video encoding than all of this 12 core 24 threads. Can you believe it? So as again, because the 5th generation newer CPU and each generation about as minimum 3% performance clock per clock in terms of the megahertz, so 15% just running guys completely frequency per frequency, the i9 9900K should be faster than this CPU, and then additional 20, I would say 25% makes sense. But this CPU is not bad, and in the end of 2021 this CPU will cost around $79-89, especially if you're 3D artist or you're creating the video encoding box. Two of the CPU and dual socket motherboard from China, let's say like $59-99, and two of those CPUs for $89 will be a great video encoding box, guys. Will be of course faster than i9 9900K when it's going to run dual socket by a lot, and great 3D rendering system as well, like 3ds Max that can utilize over 100 threads. Will be amazed guys with this box as well, especially when you're going to run dual socket. But as again, this is single socket, as you can see, and this is how IDA 64 cache and memory benchmark. Somehow when I'm running 2 core 2 threads, my read, write, and copy below 25,000 megabytes per second. When I'm running 4 core 4 threads and above in the BIOS, when 4 core 4 threads is enabled or above, like 12 core 24 threads, I'm above 30,000 megabytes per second read, write, and copy. Keep that in mind. Latency the same at the CL9 CL9, but when I'm running CL7, the latency go to 92 nanoseconds. When I'm running 6, the latency go to 86 nanoseconds. Okay, this is the maximum stable frequency on in terms of my DDR3. Keep that in mind. Even if this DDR3 is crucial, ballistics 1866 MHz CL9, but it's not stable above this frequency. So I can boot up with 14,000 megahertz on this CL9 on this memory, but it's not going to be stable, and after 20-40 minutes it's going to crash blue screen. But this is rock solid stable, guys. Keep that in mind. So 3600 megahertz was running constantly per each core, 3.6 gigahertz. This is why I disabled 10 cores and hyper-threading technology to be able to run only physical cores at maximum turbo boost. Usually it's running 3.4 gigahertz, but with my overclock through the BCLK speed frequency, as you can see, BCLK speed frequency usually running 100 megahertz, but I overclock additional by 6 megahertz, and this 6 megahertz boost times 34 will give us 3600 megahertz instead of 3400 megahertz. So no matter what is the scenario, with my BCLK overclock by additional 6 megahertz, guys, we boost up our frequency per each core. No matter what kind of scenario, what kind of turbo boost it's running automatically by the CPU, our additional frequency boost will be 200 megahertz. Keep that in mind. And right now 2 core 2 threads was running 15 megabytes per each core. Keep that in mind, because a level 3rd CPU cache is 30 megabytes shared. Motherboard is again Gigabyte X79 UD3 version 1.1, so ultra durable 3 version 1.1 with F20 BIOS, downloaded from a Gigabyte website March 19, 2014. This CPU is not going to post with any other BIOSes except this latest BIOS. Keep that in mind. And I flashed this BIOS with my i7 4930K that was running 4.2 gigahertz, but it was only 6 core 12 threads, and this is double threads. This is the best scenario in terms of the video encoding. Hopefully guys this makes sense. Titan RTX was running 16 lanes on the PCI Express version 3.0. Memory quad channel 4 sticks 8 gigabytes. DDR3 is again 565 times 2 1130 megahertz CL9 quad channel 256 bit, which is by the way as fast when I'm running 12 core 12 threads, as fast as DDR4 2133 megahertz CL14 on the i9 9900K, guys. Overclock at 5.3 gigahertz. Keep that in mind. So this is quad channel, still not bad for DDR3. As again, Titan RTX right now is running overclock 8000 megahertz on our VRAM, which is times 2 16,000 megahertz. I'm about to lower this value down my MS Afterburner software overclock. But keep in mind that Titan RTX was running completely stock Nvidia cooling solution, which is dual fan design, and Nvidia thermal compound paste. So I didn't use the liquid melt thermal compound paste yet. Keep that in mind. So guys, when I'm going to lower my MS Afterburner to stock, so the driver, Nvidia driver, will control the Titan RTX. My values such as pixel fill rate will be lowered, textual fill rate will be lowered, and bandwidth will be lowered immediately. Go ahead and have a look. And over here memory will go to 7,000 megahertz, so from 16,000 megahertz to 14,000 megahertz, because times 2. Here we go, and you're gonna see it in a second right here, guys. Immediately drop pixel fill rate, textual fill rate, and bandwidth by a lot, by the way, and memory over here is dropped as well. Alright guys, so this is it, guys. This is pretty much everything what you need to know. Let me show you that my display was running 16K resolution as well, right here, 100%, 16K resolution, which is 15,360 pixels by 8,640 pixels. Guys, don't forget to smash that like button. A lot of time, money, energy was invested just to show you this video. Hopefully you enjoyed that. This was very unique, world's first 16K resolution of Mortal Kombat XL or Mortal Kombat 10 gameplay 16K resolution. And as again in the middle, this is my system taken with the iPhone XR, and this is going to be my gaming rig with the dual Titan RTXs i9-9900K overclock at 5.3 gigahertz for 2020, my gaming rig, and this was my workstation in 2020. Thank you so much for watching. Don't forget to smash that like button, subscribe. I play 4K, AK I play 8K, AK I play 16K, or UHD King, what we do today. Have a great day, stay safe, and I will see you guys in the next videos.